Alright, in this video we're going to deal with rational equations and inequalities. When it comes to equations, there are two types. There are systems of equations. That's where you have separate equations and somehow we have to find the intersection of them, as compared with ones like this where we're just given one equation and we're just solving it. Alright, so those will be slightly different. And then of course you've got your inequalities, and those are graphed on a number line, and we've got interval notation. So it looks like we're starting with a system. When you have two separate equations in this form, you can set them equal to each other since they both equal y. So that's going to make this become 14 over, and you know what, I'm going to go ahead and factor this. So that's the difference of two squares. So that's x plus 1 times x minus 1. So I've got that. And that should equal 5x over x minus 1. Alright, now I've got this minus 2. So I've spaced this out and left all these spaces because the way I like to solve equations when there are polynomial fractions, that's what I mean when I say rational equations, I like to make the denominators the same and then cancel them out. So to make these denominators the same, this denominator will need an x plus 1 to be like that, and I'll have to put it in the numerator as well, and this denominator will need both, okay, x minus 1 and x plus 1, okay, and I'm going to need that in the top as well. I'm going to do one little shortcut though. If I put x plus 1 times x minus 1, remember, when we factored this in the first place and we put x plus 1, x minus 1, we understand that that's how you factor the difference of two squares. Well, this is a two-way street. If I see x plus 1, x minus 1, I know that that comes from x squared minus 1. So I could go either way. And for this next step, the next thing I would have to do is multiply this out anyway. So it would be more convenient, instead of writing the form x plus 1, x minus 1, it's better if I just have x squared minus 1 in the first place. Okay, now my denominators are the same, so I can cancel them out. I should probably mention my excluded values before I go canceling things out. Looking at these denominators, x cannot equal 1 because of this, and x cannot equal negative 1 because of that. So if either of these show up as an answer, I have to throw it out. So now I can cancel out these denominators and make a new equation. Alright, be careful with this minus sign. A lot of times what I like to do is I'll put the minus sign up here at the 2 like this. Bam! That way when I distribute later, I'll be sure to distribute with the negative, which is mandatory. So what I have now is 14 equals, and I'm going to distribute this, so that'll be 5x squared plus 5x, and then distributing the negative 2, I will have negative 2x squared plus 2. Okay, a negative times negative is a positive. I see some like terms that I need to combine on the same side of the equation, so 5x squared and negative 2x squared, that'll be 3x squared, and then that just leaves plus 5x plus 2. Whenever I have x squared and x, I get 0 on one side. So I'm going to subtract 14 from both sides like this. Alright, so that's going to give me 0 equals, alright, 3x squared plus 5x and negative 12. Alright, so now I'm going to try to factor this. 3x squared can only factor as 3x and x. 12 12 is either going to be 3 times 4, or 2 times 6, or 1 times 12. So I've got some options. I'm just going to go in this order. So if I do 3 times 4, I know not to put the 3 here because that would make a common factor with the 3, and that shouldn't happen. So I'm going to try 4 and 3 instead. Inner plus outer must equal middle. Inner, I have 4x. Outer, I have 9. I can get a positive 5 out of this if I make this negative and this positive. That means this would be negative and this would be positive. A negative times a positive is a negative for the negative 12, so this is good. Now I'm just going to set each of these equal to 0. So if I set 3x minus 4 equal to 0, and I set x plus 3 equal to 0, I'm going to get x is equal to 4 over 3. I added 4 divided by 3, so 4 over 3. And here I'm going to get x equals negative 3. So these are the two solutions to this equation. Are either of these excluded? No, both of these are fine. Now this is not my final answer. These are just the x values of my answers. So I'm going to have two, because look, when you are solving a system, when you have two different equations, you need ordered pairs. You need x's and y's. So what I have so far are the x values. So I have 4 over 3, and I have negative 3. Those are my x values. I need the y values to go with them. How will I get those y values? Well, these equations deliver y values, so just pick one of them. I'm going to go ahead and pick this one, and I'm going to use my calculator to help me out. All right, go to your table function, and I'm just going to type this in, 14 over x squared minus 1. All right, I'm going to use Ask X mode, so I recommend you do the same. And I have two values I need to evaluate, 4 thirds and negative 3. So I can just type them in, 4 over 3 and negative 3. So these are the two y values that go with these x values, 18 and 7/4. And that's it. So that's the answer to number 7. Now I see that number 8 is an inequality. I see that less than sign. These are the ones where we make a number line and we plot some test points. We put some critical values. Sometimes they're open, sometimes they're closed. And then we'll do some test points to see where the solutions are. Maybe we'll get a yes, no, yes. And the graph will look like this. So that's just an overview. If you have no idea what I was just talking about, well, here it is. First of all, remember that number line I was mentioning? We need a way of finding what the critical values are that we need to plot on that number line. One way that we find critical values is we solve the related equation, which I'm writing down incorrectly. Let me try again. We solve the related equation 2x minus 7 over x minus 5 equals 3. All right, solving this will give us one of the critical values. So the way I'm going to solve this is I'm going to make the denominators the same. So here's my x minus 5, and I have to put it in the numerator as well. Now that my denominators are the same, I can cancel them out and make a new equation. So this would be 2x minus 7 is equal to 3x minus 15. So I don't see x squared anywhere, so I'm just going to get the x's on one side and the numbers on the other side. So I'm going to subtract 3x from both sides. So that'll give me negative x minus 7 is equal to negative 15. And then I'm going to add 7 to both sides. All right, so that's going to give me negative x is equal to negative 8. dividing by -1, x is equal to +8. So that's one of the values that is going to go on my number line. So here's my number line. All right, so so far I have x equals 8. That has to go on the number line. In addition to that, we need any excluded values. So looking at this denominator, I know that x cannot equal +5. So these are the two values for the number line. So I'm going to have 5 and 8. Excluded values will always be graphed as open circles, because an open circle means that the value is excluded. On the other hand, the solutions to the equation are sometimes open circles and sometimes closed circles. It depends on this symbol right here. If it's less than or equal to, the equal to means that we want to include points like 8 where the function is equal to 3, and that's what we just solved for. So we're going to include this because we want the equal to points. If this was just less than 3, then I would have put an open circle. Okay, now we have these 3 zones. We're going to need a test value in each zone. So over here to the left of 5, I'm going to do 0. You could do 4, 3, 2, 1, 0, -1, anything less than 5. Here between 5 and 8, I'm just going to go ahead and do 6. Could have done 7. To the right of 8, I'm going to go ahead and do 10. Could have done 9, 11. So your values don't have to be exactly like mine. So to evaluate the function at these values, I'm going to just evaluate the left side and then see whether or not they are less than 3. So and I'm going to use my calculator to help me out again. So table function, so I've got 2x minus 7 over x minus 5. So 2x minus 7 over x minus 5. All right. Make sure your calculator is in Ask X mode. So I have these 3 values I want to evaluate: 0, 6, and 10. So 0, 6, 10. All right, so I get 7/5, 5, and 13/5. So I get 7/5, 5, and 13/5. Don't forget, in each case, we're asking ourselves whether or not it is less than 3. I'm not saying equal to 3 because we already found out that 8 is the one value where it's equal to 3. So that just leaves less than. So that's why I'm saying just less than. So is this less than 3? Is this less than 3? Is this less than 3? That's the question. 7/5. What's the deal there? 7/5. So that's 7 divided by 5. That's 1.4. So that might just be good to keep in mind. The decimal version, so this is 1.4. Okay, is this less than 3? Yes. Yes, it is. Is 5 less than 3? No. What about 13/5? Well, that's 13 divided by 5. That's 2.6. Just keep that in mind. 2.6. Is 2.6 less than 3? Yes. So these yeses show us where the solutions are. So we have solutions to less than 5, and we have solutions greater than 8. So that's a graph of our solution set, but we want interval notation. So This first arrow over here on the left goes from negative infinity to 5, and I'll use a parenthesis to show that this is not included, open circle. Now, union and this arrow goes from 8 to infinity. So because this is a closed circle, I'm going to use a bracket, which also means including 8. All right, so it goes from 8 to positive infinity. So that is the final answer for number 8. Number 9 and 10 are simply asking about excluded values. The denominator cannot equal 0, so the excluded values are all about the denominator. So here, this factors as x plus 4 times x minus 4. So these two factors will give us excluded values. So if I set x plus 4 equal to 0, that gives me x equals negative 4. That means x cannot equal negative 4. If I set this equal to 0, I get x equals positive 4. So x cannot equal positive 4. All right, so notice even though these cancel out, it doesn't stop it from being an excluded value of 4. There's still 2 excluded values anyway. All right, so similarly, I will factor this business. Actually, I'm not even going to factor the numerator because it doesn't matter, only the denominator. So if I factor this, x squared is x times x. 21 is surely going to be 3 times 7. To make negative 4, right? Inner plus outer equals middle. Inner, I have 3x. Outer, I have 7x. To make negative 4, I need a positive 3 and a negative 7. And positive times a negative is a negative 21. So there I factored it. So because of the x plus 3, x cannot equal negative 3. Because of the x minus 7, x cannot equal positive 7. So those are the excluded values. Doesn't matter what the numerator was. Okay, let's see how many of these we got. All right, so now we just have a couple of equations left. Notice this is going to be very similar to what happened on problem number 7, except for on problem number 7 we had 2 separate equations until we combined them into one, setting them equal to each other. When we had 2 separate equations, we had to find the x's and the y's. But if you're just given equations, all right, already set equal to each other, just a single equation, we're just going to find x and be done with it. So here we go. We like to find like denominators. There are other ways to solve equations, but this is my favorite way. So that's obviously the way I'm going to teach it. Interesting, I really would normally divide these. 3 goes into 15 5 times. So if I divide 3 into 15, that'll make 5, which is the same as this. So that's what I would normally do. That's the best way, the fastest way. However, most students won't notice that. So I'm going to go ahead and do it the way that most students would probably do it. So we need like denominators. So I'm seeing the 5 can be turned into a 15 if I multiply by 3. I have to do it in the top and the bottom. So now this is 15x, but this is just 15, so I need an x. All right, top and bottom. This is just an x, so I need the 15. Top and bottom. Okay, Let's mention the excluded values right now. Just looking at the x, or the 5x, that tells us that x cannot equal 0. So be careful, because if 0 turns out to be one of my answers for any reason, I will have to throw it out. So now that I have like denominators, I can cancel them out and make a new equation looking at the numerators. So this will be 6 is equal to negative 3x plus 15. I only see x, not x squared, so I'm just going to get the variable on one side and the numbers on the other side. I think the fastest way to do that will be to subtract 15. So that's going to give me negative 9 is equal to negative 3x. Then I can just divide both sides by negative 3. Alright, so these cancel out, and I get x equals 3, positive 3. And that is not excluded, so that's the answer to the equation. All right, last problem. I am going to factor so I can see exactly what I have. So give myself a little bit of space. All right, so when I factor this denominator, x squared is x times x. 18 is 3 times 6, among other things. And I want to make negative 9. So inner, I have 3x. Outer, I have 6x. To make negative 9, both of these have to be negative, which is fine because a negative times a negative is a positive. So x minus 3 times x minus 6. And meanwhile, here I just have x minus 6. And this trinomial is the same, so it must also be x minus 3 times x minus 6. Meanwhile, in the numerator, here I had 5x minus 20. Here I had 1. And here I had x minus 4. So far all I've done is I have factored. Now I need to make the denominators the same. Now 2 of the denominators are already the same. If I want this one to be the same, I'm going to have to multiply by x minus 3. And to keep the balance, I have to multiply the numerator as well. Let me mention the excluded values before I go canceling things out. Because of the x minus 3, x cannot equal positive 3. Because of the x minus 6, x cannot equal positive 6. Okay, I guess that's it for excluded values. So now, the denominators are the same, so I can cancel them all out, and I can make a new equation using the numerators. So I have 5x minus 20 plus x minus 3 is equal to x minus 4. Okay, I mean distributing 1 or whatever, you just get x minus 3. So I have some like terms over here on the left side of the equation. So 5x and x, that's 6x. Negative 20 and negative 3, that's negative 23. And that's equal to x minus 4. I only have x's, no x squared. So that means I'm just going to get x's on one side and the numbers on the other. So imagine that I subtract x from both sides. So that's going to give me 5x minus 23 is equal to negative 4. Now I'm going to add 23 to both sides. That's going to give me 5x equals 19. So now if I divide both sides by 5, I get 19 over 5. Just leave it as a fraction. Don't give me the decimal, please. So the answer is x equals 19 over 5. And that is not one of the excluded values, so that is the final answer.